the good news is that my presentation is the last one. And my name is Ziquan from class of China. Sorry. And the topic of my presentation is the influence of Doppler effect on the wheel real dynamic test in high-speed railway lines. This presentation has 6 parts. As introductions, real wheel bending real velocity, investigation or test train and track. There are 2 dynamic tests to verify the Doppler effect. One is the Polygon wheel dynamic test, and the other is the real corrugation dynamic test, and then is the conclusion. So as we know, the Doppler effect is the change in frequency for an observer who is moving relative to the source wave. In classical physics, the relationship between the observed frequency and the emitted frequency is shown as this formula. The velocity of the receiver and the source relative to the material is larger, the Doppler effect is more evident. And in China, the speed of train, the operation is 350 kilometers per hour. So the Doppler effect in dynamic test or high-speed railway should be considered, I think. There are 2 important wave lengths in noise and vibration. One is the longitudinal wave, and the other is the bending wave, I think. So in order to get the real bending wave formula, the real is simplified into the Euler beam. And this picture shows the vibration mechanism of the real element. And based on the real second Newton's law and the Euler-Bernoulli beam theory, we can get the real bending wave velocity like that. Like that. And in China, the real bending velocity is based on the frequency from this formula. In China, the CL is the longitudinal wave velocity is about 5,200 meters per second. And the T is presented the height of rail. In China, this parameter is 176 millimeters. So based on these parameters, the real bending velocity can simplify this. Now we got we got the formula and the and the Doppler effect. So we have to design some tests to verify the Doppler effect. The first is investigation of the test train and track. The test train includes 8 cars, 16 bogies, and 32 wheel sets. Investigation measures all out or around the wheels are carried out using the mini-prof in depot. The left picture is show the measured result of 1 to 7 cars, and the right picture shows the last cars, the 8th cars of the wheels. So it's the from this picture, from 1 to 7 cars is well, and the wheel of the last cars is the Polygon wheels. And the second is the test track. We choose two sections. The test track is ballast track with Fusslow 3000-1 fastening system. Two sections of track are chosen as the test track. The one is there is no obvious real corrugation, and the other is how the typical obvious real corrugation with the typical wheel length of 136 millimeters wheel length. Based on the investigation, we have two test conditions. One is the train with 18th order Polygon wheel, and the track is well. And the other condition is the train is well, and the track have the real corrugation. So the purpose of test condition 1 is to verify the Doppler effect of wheel rail vibration by Polygon wheels, and the condition 2 is verify the Doppler effect by the real corrugation. The dynamic test will carry out. The dynamic test includes the wheel real force and real acceleration. Wheel real force was measured by Xiao method using the strain gauge, and the real acceleration was measured by accelerometer with 1000 gravity range. The real force sensors was installed mid-span. In mid-span of the rail, and the real accelerometer was set on the rail seat. The operation speed of test train is 300 kilometers per hour passed by the sensors. The test result was, yes, this is the test result. The left picture is the wheel real force, and the right is the real accelerations. And last presentation, my colleague showed that the values. So I chose one cast and the last cast to do the fast flow rate transfer to find there are two obvious frequency. One is 570, and one is 613 hertz. Because the test condition is same except for the wheels. The last wheel is the Polygon wheel, and the others wheel. So this frequency was generated by the Polygon wheel. But the Polygon is 18 orders. So based on this classic formula, it should be one excitation frequency. But there is no 562 hertz in test results instead of 2 hertz, two frequency. So when we considering the real bending wheel velocity, the real bending wheel is calculated by this formula. Is 962 meters per second. And based on the Doppler effect, we can calculate the frequency F1 and F2. So this F1 is obtained is 517, and frequency 2 is 615. So it's similar with the test results. So we could see we verified Doppler effect by the Polygon wheel dynamic test. And the next test is the real corrugation test. The wheel or trains is well. Only is the real surface how the real corrugation is the test condition 2. The speed of test train is 246 kilometers per hour passed by the sensors. And the test result, this is the real acceleration of test result. We can divide this DOM figure into 3 parts. One is the zone A, is the time of before the train put into the sensors. And the B is the time of train put into the sensor's position. And the C is away from. After the train pull out, is the 3 zones. We can, we can do the fast flow rate transfer. The time DOM of A zone and its PSD. We found there's only one frequency, and in the zone B, yeah, there are 2 obvious frequencies, and the C is only 1. So when the test train passes through the sensors with speed of 246 kilometers per hour, the excitation frequency of real corrugation with wavelength of 136 millimeters is about 501 hertz, calculated by the classic formula. But in the test result, it's instead of 2 obvious frequency. So we also considering the Doppler effect and the real bending wavelength, wave velocity, and we can calculate the real bending wave and the frequencies. So we can also obtain the F1 and F2 is the same same with the test results. So in summary, the velocity of real bending wave could be obtained by the formula as following this formula, yes. And then we do 2 dynamic tests to verify the Doppler effect and to verify the formula. So that's all. Thank you.